All right, pre-calculus, this is the last section. We are on lesson 4.8, and this is very similar to what we did in the past with right triangles. We're solving real-life problems involving right triangles. So we're going to look at some applications and models, and we're going to be using our calculator, so make sure you have your TI-84 ready to rock and roll. Question number 1 says, solve the right triangle shown where A is 20 degrees and B is equal to 15. So it looks like they want us to show the rest. Well, the first thing I know is they told me that A is in 20 degrees, so guess what I want my calculator in? I want it in the mode of degrees. So the first thing I'm doing is I'm going and changing my calculator mode, and that's going to be really important on test day. Now, in order to find A, I know opposite over adjacent is tan. So I'm going to use the tan of 20 degrees and make that equal to the opposite over adjacent, which I know is 15. I know I can multiply each side by 15. 15 tan of 20 degrees is equal to A. So right now I can solve for A. I'm just going to push pause and put it in my calculator. All right, I got A is equal to 5.46. It was 5.9, but I just rounded up to 5.46. So I do know what A is. Let's see if we can find what C is. Well, I have adjacent over hypotenuse. SOHCAHTOA, I know that is the cosine of 20 degrees, is equal to adjacent over hypotenuse. When I multiply each side by C, notice that I have to put the C in the numerator first. So in order to solve for C, I'm going to take 15 divided by the cosine of 20 degrees. So when I put that in my calculator, 15 divided by the cosine of 20 degrees, I do get 15.95. All right, great job. We answered the question. We got A is 5.46. C is 15.95. Oh, we forgot something. I forgot angle B. I can find angle B because I know this is 90 degrees. This is 20 degrees. And I know all angles of a triangle add up to be how many degrees? So B, yes, 180 degrees, is 70 degrees. All right, so let's see what else the next question is bringing to us. A ladder 16 feet long leads against the side of a house. Well, you know me, I like to draw pictures. So here's my house, and a ladder 16 feet long leans. So I know that this is 16 feet long. And look, it makes a very convenient right triangle for us. Find the height, h, from the top of the ladder to the ground. So I'm looking for this height, h, from the top of the ladder to the ground if the angle of elevation of the ladder is 74 degrees. 74 degrees. Once again, I know that my calculator needs to be in degree mode. And I have an opposite and a hypotenuse, so I know that the sine of 74 degrees is equal to opposite h over hypotenuse 16. I can multiply each side through by 16. And when I check this on my calculator, I get 15.4 feet. So it says, find the height, h, from the top of the ladder, which was here, to the ground, which is here. So it looks like this ladder, or the height of the house, is 15.4 feet. All right, next question. Let's see if they're getting a little, ooh, my artwork is getting a little better. Just kidding, that's a horrible airplane. From the time a small airplane is 100 feet high, it's drawn for you, and 1,600 ground feet from its landing runway, the plane descends in a straight line to the runway. Determine the plane's angle of descent. So it sounds like we're looking for this angle right here. And remember, my calculator currently is in degrees. So it looks like I could use tan. The tan of x is equal to opposite over adjacent. So how do I put this in my calculator? All right, so this is where it gets to be a little confusing because a lot of you guys don't know how to do it. The first thing I would do is find out what 100 divided by 1600 is, and I get 0.0625. So the tan of x is equal to 0.0625. Now, you can take second tan, second answer. Okay, I'm going to write that down. The buttons that you're pushing are second tan, second answer. Now, answer is the negative sign underneath the 3, okay, but we're looking for the answer. And that's putting this in the inverse of tan for us. And this is the whole point of the lesson because we've been doing inverse of trig. So when I do that, I get 3.58 degrees. So they're saying that this little angle that this plane is coming in at is 3.58 degrees.